Alright guys, today we're going to talk about properties of special parallelograms. A special parallelogram can be considered a rhombus. A rhombus. A parallelogram with 4 congruent sides. So all of our sides are congruent. Okay. Discover properties of a rhombus. Well, let's go ahead and talk about this rhombus before we do that. Okay. We can go ahead and we can draw some diagonals here. Please remember that this is a computer, so they might be slightly off. Okay. We're close. All right. So cool thing about rhombi. Yep, that's how we call them when there's more than one. It's not rhombuses, it's rhombi. Okay. They are perpendicular and they are bisectors. Okay. And they're angle bisectors. Okay. Because their opposite angles are congruent, so we bisect them. Okay. So go ahead and make your rhombus look like mine. And then we'll continue. Discovering properties of a rhombus. Given that the figure below are rhombi. Yep. See, there you go. Find the measures of the numbered angles. So we're going to find angle 1, 2, 3, and 4 for the first one. Remember that our diagonals perpendicularly bisect each other. So therefore, let's do it on this side. They are going to be right angles. Okay. In the next one, we can look at this. This is still a rhombus. Okay. Those opposite angles are congruent. So this one is congruent to this one. And this one is congruent to this one. But remember, they are bisected. Okay. So the measure of angle 1 is congruent to, let's make that congruent. There we go. The measure of angle 3 and the measure of angle 2, and that's congruent to the measure of angle 4. Okay? Just like the measure of angle K is congruent to the measure of angle M. Okay? All right, let's talk theorems. Go ahead and pause the video for a second so you can write. Well, actually, let's finish this and then you can write them down. Theorem number 1 says each diagonal of a rhombus bisects 2 angles of the rhombus. Okay, those are the opposite angles. The next one says the diagonals of a rhombus are perpendicular bisectors. Okay. If one diagonal of a parallelogram bisects 2 angles of the parallelogram, then that parallelogram is a rhombus. RHOMBUS. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay? And we already marked the one at the top, so that would work out perfectly. All right. Let's go on to the examples. Example 1 says, MNQP is a rhombus. And the measure of angle Q is 120 degrees. Find the measure of the numbered angles. So we know that this one here, is 120 degrees. That makes this one 120 degrees. Okay. So one of the things that we can do is we can look at this and say, okay, we've got this rhombus, which has two triangles. In a triangle, we have 180 degrees. Okay. And that equals 120 plus angle 2 plus angle 3. Okay. So now we can go ahead and just add them. What we're going to do is subtract 120 minus 120. Okay. Let's call this x. So we've got x and x. Okay. So we get 180 minus 120, which gives us 60, equals 2x. We divide by 2. X equals 30. So the measure of angle 1 is 30 degrees. Angle 2, angle 3. And then the measure of angle 4 is also 30 degrees. Okay. Example 2, find the measures of the numbered angles of the rhombus. Okay. So all we have to do, let's go ahead and zoom. If this one over here is going to be 50, okay, we've got each of these in a triangle. We know that angle 1 is 90. So the measure of angle 1 is 90 degrees. Okay. If this one is 50, guess what? We know for a fact that angle 2 is 90 degrees. Okay. And 1 and 3 are going to be congruent. Okay. So now we can go ahead and say that, 2 is not that one, it's 50. My bad. Now I can say 180 equals 50 plus 90 plus angle x. We'll just call this one x. Okay. Well, 50 plus 90 gives us 140. Okay. So we say 180 equals 140 plus x. We subtract 140. And we get 40 equals x. Okay. So if this is 40, that means that angle 3 is 40 and angle 4 is 40. So the measure of angle 3 is 40 degrees, and the measure of angle 4 is 40 degrees as well. Okay? Alrighty. So, looking at this next one, solve for x, we know that this one is congruent to this one. Okay? And this one is congruent to this one. So we can go ahead and do some math here to find out what x is. Okay, I like to say 8x minus 6 plus 2 times 4x plus 5, because remember, those are opposite angles, so they're going to be congruent. Okay, equals 180. Okay, we can distribute our 2, so we get 8x minus 6 plus 8x plus 10 equals 180. Combining our like terms, 8 and 8 is 16. And then negative 6 and 4 and 10 is positive 4. Subtract 4 from both sides. We get 16x equals 176. We divide by 16. And we get x equals 11. Okay. All right. Another way to look at these, by the way, is, let me get rid of these real quick. Just looking at this one triangle here, I have an isosceles triangle, so we've got our angles at the bottom have to be congruent. Okay? All right, the next one. The diagonals of a rectangle are congruent, and the diagonals of a parallelogram are perpendicular. Then if the diagonals of a parallelogram are perpendicular, then it is a rectangle. We're going to skip example 4 because, again, that's another proof, but we're going to look at example 5. Find the length of the diagonals of a rectangle GFED if FD is 2y plus 4. Ooh. Let's try that again. This one is 2y plus 4. And GE is 6y minus 5. Okay, now remember, the diagonals are congruent, so we go like this. We say 6y minus 5 equals 2y plus 4. Okay, now I can go ahead and move things around. So minus 2y minus 2y, 4y minus 5 equals 4. Add 5 to both sides. We get 4y equals 9. Divide by 4 on both sides. We get y equals 9 over 4. Okay, since we have to find the length of the diagonals, we do have to plug that into one of them. I'm going to plug it into DF, or FD. So we say 2 times 9 over 4 plus 4 equals FD. Okay. 2 times 9 gives me 18 divided by 4 plus 4 equals FD. 18 divided by 4 is about 4.5 plus 4 equals 8.5. So FD equals 8.5. Okay. Example 6. Determine whether the quadrilateral can be a parallelogram. Okay. There we go. The quadrilateral has congruent diagonals and one angle is 60. That's going to be a no. No. A 60-degree angle would be too small. The quadrilateral has perpendicular diagonals and 4 right angles. That tells me that it is going to be a rectangle, so that will be a yes. Okay. Example 7, a diagonal of a parallelogram bisects 2 angles. Is it possible for the parallelogram to have sides 5, 6, 5, 6? Probably not. Okay. If it bisects if the diagonal of the parallelogram, so let's do this. Okay, if it bisects this, can the sides be 5, 6, 5, 6? Oh. Bisects 2 angles of its parallelogram. That's actually a yes. That's what happens when you read this too quickly. This can be 6 and this can be 5. Okay. All right. There we go. Now we've got Paul over here. We're going to do example 8 and then we're going to move on to squares. Okay. So Paul is training his horse to run a course at the pace of 4 meters per second or faster. Paul rides his horse from D to C, and then C to E, and then to B. Okay. He does that in 1 minute and 30 seconds. If the figure ABCD is a rectangle, did he make his goal? So here's what we're going to do. Well, I like to look at this as in different ways. Okay. The first thing I like to do is I like to look at this and say, hey, I have a right triangle. Okay. With that being said, we also have a rectangle. So this is 80 meters and this is 192 meters. Okay. Let's find out what it is from D to B. So we say 80 squared. 80 squared plus 192 squared equals C squared. Okay. When we do this in our calculator, we get 6,400 plus 864 equals C squared. When we add those together, we get 43264 equals C squared. We square root both sides. So we get C is 208 meters. Okay. So with that being said, we know that it is bisected. So this side over here is 104. 104. This is 104. Okay. Let's actually, oopsie. Let's put it on this side. 104, 104. This side's 208. That means that this is 104 as well. Okay. So when we're looking at this, we kind of take into account what we've got. Okay. So we're going to do some adding now. 192 plus 208. Okay. Because he does do 2. That's going to give us 400 meters. We divide that by 90 seconds because a minute is 30 seconds or 60 seconds and half is, and then you had the 30. So 60 plus 30 is 90. We end up with about 4.4 meters per second. And he wanted to do this in 4 meters per second or faster. So no, he did not. Sad day. Okay. Let's go on to squares. These are pretty important things. All right. A square is a parallelogram with all right angles and all sides being congruent. A square has all the characteristics of a rectangle and a rhombus. Okay, so let's mark this up a little bit. We've got all right angles. All of its sides are congruent. But remember, it also has all the characteristics of a rhombus. So we've got our diagonals. Okay, that one didn't look so hot. Let's fix this so it looks right. Oops. Okay. There we go. And in the other direction. Okay. Our diagonals are perpendicularly bisected and congruent. Okay. So a square ABCD has a diagonal AC and BD. Let's go ahead and draw that square. Okay. We've got right angles. All of our sides are congruent. Perfect. We've got A, B, C. I don't know what that was. B, C, and D. There we go. Okay. Diagonals AC and BD. What is the measure of angle ABD? Okay, so when we look at this, there we go. Let's go ahead and get our ruler back. ABD. We're looking for this angle here. Okay. Well, it's going to be half of 90 degrees, right? Because all of them are those 90-degree angles. So we're going to say 90 degrees divided by 2 gives us 45 degrees. Okay. And that is it for today. I will see you in the next one.